Here we are on the second video of the first semester review for math analysis. We're going to find all the rational zeros of the function. First thing we need to do is we need to factor this thing. So I'm going to take, if I'm going to find my zeros, I need to set this equal to 0. And then I'm going to factor out my common denominator. Looks like 3x squared will do it, leaving me with x squared minus 9x plus 18. And then we need to simplify or factor this trinomial. And it appears as if x minus 6 and x minus 3 will do it. And so I get a 0. I get multiplicity of 2 on that 0. And I get a 6 and a negative 3 are my zeros. All right. A certain population increases with this model. Looks like we have an E. So we're going to put t equals 9 in here. So I'll have 280 e to the 0.047 after 9 years. Let's put this into my calculator. I get 0.047 times 9 equals, then I'm going to take that, put it on top of e, so e to that amount, e to the 0.423 gives me 1.5265, and then multiply that by 280, and it appears as if the population of this place is going to be 427 people. Notice that I rounded to the nearest person. We don't use decimals when it comes to people. In this one, we're asked to find the domain, and we know that our domain, because this is a continuous function up here in the numerator, that the only place where our domain is not defined is where the denominator is equal to 0. So if I factor the bottom, I get x plus 3 and x minus 3, which gives me negative 3, and 3 are my places where it's not defined in the domain. So I would say all real numbers except negative 3 and 3. The other way to write that in interval notation would be from negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. You should know both those interval notation and the set builder notation. If I'm going to graph this, we know that we have a vertical asymptote where our denominator is equal to 0. We'd call that negative 2. And we know that since the power on x is bigger on the bottom than the top, that we have a horizontal asymptote at 0. And then if we take a little time to find some points here, if I plug in 0 for x, making a table here, if I put 0 in for x, I get 6 divided by 2 is 3. So 0, 3. I have a point. And if I try a point over here at negative 3, I get negative 6. With that in mind, I have the idea that my graph is going to kind of go like that, and it's going to curve and follow the asymptote up, and over here it's going to curve and follow the asymptote both those directions. All right, let's stop here. We will have another video in a little